Here's a live example of using the data surfaces in Femap version 9.3. The data surface editor is already open. If it wasn't open, you can actually just toggle it on and off with Tools, Data Surface Editor. What I'm going to do now is create a simple 2-point data surface and just give it a title. Now just simply pick from the screen. I'm just picking 2 points in space. There's a group set up in this model so that the only points are the ones at the ends of this rectangle that's been laid out. But I can just pick both of those, put in a temperature at one end of 70 degrees, at the other end of 130, and say OK to create the data surface. It's now been created. If I go in the model tree, it's already there. It's ready to be used. So I'll go create a thermal or nodal temperature thermal loading. Say nodal. I'll pick all the elements on the solid. They're all in group 5. And then we go temperature. And here I'll just specify a 1. We could actually use a multiplier on the data surface and double it by entering a 2. But in this case, we just want to go straight with the numbers that were already calculated, 36,000 of them. At this point, the nodal temperature has been applied to the model. Just to visualize that, we'll use model output, create a new empty output set, and now we'll just look at the temperature distribution by calculating one from the existing loading. So I'll just say create model output from loads, from the temperatures, and it creates new output data that is the nodal temperatures, and we can just take a peek at that as a contour. And I'm going to turn off the element edges. And we'll see that that varies very nicely from the 70 degrees like we specified up to the almost 130. Looks like there's a little round off there at the end because it doesn't go all the way. But now it's a nice temperature distribution. And what we did now, I've already run these. So here's this model run, and there's actually some support beams underneath this structure that's applying stiffness in this direction. But then if we load that up, we'll see we get a maximum displacement of 0.0174. We'll create a 4-point data surface this time and actually vary the temperature from the 4 different corners of this model. So just like last time, I'll go in and create a new between points data surface, and this time we'll do a 4 point, so it is a bilinear temperature distribution. And we'll just pick the points. This time we'll go up and pick the 4 corners, and we'll set up a temperature distribution in the top left corner of 40, bottom left of 50, bottom right of 70, the top right of 130. I'll say OK to create the data surface, and it's over here ready to go. So now we'll just apply that as a load. Model load nodal. We'll pick all the nodes on the solid, and just like before, we'll use a factor here of 1 and take the load straight out of the data surface and apply them. The calculation is finished, so I'll go ahead and cancel out, and we'll just create output again to visualize it, make sure it did what we thought it did. So I'll create an empty output set, and then create some output data from the existing loading. So just right from the temperatures. Now I can go into a contour plot of that data. We'll see that it does vary as expected. Turn off the edges again and make it a little prettier. Looks like about 40 degrees here, 50 here, 70 in the 130. So it's doing exactly what we thought. And here's a Nashville model of a deflection due to that thermal loading. So we can see that that's actually a little less than last time. Now let's go on to the next example. In this example, we'll use the results of a separate thermal analysis to apply loads to this model. So I've got my solid model up. I'm going to bring up my shell model that contains the temperature results. And then we'll just tile the windows so we can see them both at the same time. And what we want to do is actually extract the data from this one and then apply it over on this model here. From the shell model, we'll actually create a mesh output data surface. Pretty much all you need to know is the title and then which vector the data is. And this is all in one vector with nodal temperatures. Say OK. Basically fills in this data surface. And I'm going to copy this simply to the clipboard. And now I need a couple node points in here so I can align this later on. I know that the two things are not correctly aligned, so I'm going to do list model node. Just list these two nodes, and we'll use them as an alignment vector later on. So let me grab this information. I'm just going to copy it to the clipboard, throw it in Notepad for when I need it later on. So let's bring that data surface over to here. We're going to copy it, go to the other one, paste. Now we just want to see what it looks like where it's at, so we're going to plot it. And as I already knew, it's not aligned, so I need to get it down there and aligned to this data. So what I'll do is, there's a tool built into the data surfaces that says align. And I want to go from a vector that is X, Y, Z right there, 587. Hitting the tab key in between things with 5, 23.29, and then the Z value of that. So there's my initial vector, and it looks like it lines up on that mesh correctly. And then I just want to get it down to here. And what that'll do is just bring the data surface down to there. So now it's in the right place for the creation of loads. And just like the other examples, we'll create model, load, nodal. And we'll select all the nodes on the solid because they're in that group. And again, we'll go 1.0. And the data surface this time will be that mapping data surface. And it will run and do the same type calculations. This time it actually has a mesh to back it up, not just a linear field or a bilinear field. It's actually projecting the nodes into that mesh and figuring out what output value is at that location and bringing it back and applying it as the nodal temperature. So we'll just let that finish. There we go. And I'll say cancel. Don't really want to create any more nodal loads. I'm going to shut down the thermal model. And then just double click that to bring it full size. And let's just take a look at that load distribution like we did before. Create an empty output set. And create some output from the temperature loading. We'll see how well that mapped. There's our data. Looking pretty good so far. You see we get pretty much the same distribution we had in our other model. Looks great. Again, I've already run this in Nastran, so we'll just take a look at the results and see how the displacements compare. And this is actually our worst case due to the temperature distribution. It's bowing up a little bit more than the other ones. So that's an overview of using Femap version 9.3 data surfaces.